Hello, this is Scott Christensen and Nathan Swain. It is February 7th, 2013, and we are recording a video that demonstrates a script that we wrote that functions as a tool in ArcGIS that creates a map book of PDF maps using Huck8 watersheds. We're going to start by going over the organization of our code and mainly the geoprocessing aspect. We designed the geoprocessing using Model Builder in ArcGIS, which takes 4 inputs. The Huck8 is a shapefile of Huck watersheds. We also take a DEM, which is the elevation model of the area of interest. The threshold is the number of cells that we use to determine the stream network, and then we have the PDF atlas, which is the output file that's generated by the tool. We first iterate through all of the shapes in the shapefile and using the select tool, create a new shapefile, which we use to extract the DEM to get the DEM of just the area under the watershed. We then use the fill tool, which prepares the DEM for calculating the flow direction, which calculates the direction of flow of each cell of the DEM. We can then calculate the flow accumulation for each cell, and then using raster calculator are able to delineate the stream network using the threshold input. We then use the stream link tool to link the streams together in sequence, and then we can use the stream to feature tool, which creates a polyline of the streams. Using the vertices to points tool, we are able to create outlets using the endpoints of the streams, which we then feed into the watershed tool to delineate subbasins of the Huck watershed. Using the raster to polygon tool, we convert those watersheds into a shapefile with polygons. And then this is not a tool that's actually used in ArcGIS, but it represents what our script is doing. It generates a map and creates a PDF version of the map. Here we have the actual code of our script. As you can see in our header, we have licensed it under the MIT license, which means that it's open for any kind of use. We first import some necessary modules. The ArcPy module allows us to do all the geoprocessing, and then the operating system and the system module allow us to do some other functions that we need. We have broken our script into 3 main functions. We've got the initialize function, the geoprocessing function, and finally the generate map function. I'll walk you through each of those functions briefly. In the initialize function, where we start, we first set some of the environment variables in ArcPy. We then define the geodatabase by getting the base path of this script where the geobase is stored. It's distributed with the script. We then have some code that takes all of the user inputs, the DEM, the Huck shape file, the threshold value for stream networks, and the path to store the PDF output. This last part of the initialize function sets up the PDF file for appending to. We first create the PDF file. We then append a page, which is the title page that we distribute also with the script. We save and close it, and then we start our geoprocessing. To our geoprocessing function, we pass in the base directory, the geodatabase, the DEM file, the threshold value, and the Huck shapefile. In our geoprocessing, we first set up some variables that we use in generating all of the geoprocessing tools. We then use a search cursor to access the attribute table of the Huck watershed shapefile. And then we have a for loop which iterates through each of the features in the shapefile. These functions are all the functions that we outlined in our model builder. It's the same geoprocessing that was overviewed there. The last function of our loop calls the make map function, which creates the PDF version of the map of the output. We pass in the geodatabase, the watershed name, the HUC file. Clip watershed is the selected watershed that's featured on the map. The subbasins is the output of the sub-watersheds that are delineated, and streams is the stream network that was also generated in the geoprocessing tools. Here we have we print messages. This is a function that we defined that prints messages both to the console and to the ArcPy console when the tool is run, so that we can see the progress of the tool as it runs. Here we create a variable that gets the map document, which is also distributed with the script. Here we are getting the data frames of the map document. We then call the describe function to get some properties of those data frames. Mainly we're looking for the extent property, which we then use to scale the extent. Here we set the extents of these data frames to be the same extents as the shape files that we're passing in, and then we scale them by 10% so that there's a little bit of a buffer around those files. We then access the layers of the watershed's data frame, and we change the data source on each of the layers so that they map to the input that we calculated in the geoprocessing function. We then get the layers of the inset map. We also pass it the shape file so that it's able to highlight that in the inset map, and we give it the HUC watersheds so that it is able to handle that dynamically and take whatever shapefile of watersheds is passed in. We then change the text element on the map to display the name of the watershed, and then we generate a PDF version of the map. Oh, here we're actually getting setting a variable equal to that map document that we started and created up above. We then open it and append the PDF version of the map that we just created. Again, we save and close it. We delete the MXD variable that points to the map so that we don't save any changes, and we delete the temporary PDF that we created. Here are three functions that we created that we use as utilities throughout the rest of the script. Print messages, like I mentioned before, prints both to the console and to the ArcPy message dialog. Change layer source is just a wrapper that we made around the replace data source function of ArcPy. We made it so that it is a little more user friendly. And then we created a function that is just a general utility function that splits a file path into the path and the name of a file. This last section of code is the first thing that's actually executed after all the functions are read in. All it does is call the initialize function to start the code running.
Hi, this is Nathan. I'll now walk you through the software demonstration portion of our presentation. First, I wanted to show you the contents of the digital watershed zip file that you'll receive when you request a copy of our software. This folder, when you extract it, will contain the following: this digital watershed geodatabase, documentation folder, the map temp directory, this digital watershed map file, and the digital watershed Python script that Scott just finished explaining. The map temp directory contains this digital watershed title page.pdf that's appended to the map document at the beginning of the process. If you would like to put a custom title page, just replace this one with the same name. The last thing that's important is when you extract this, make sure that you extract it to a location where you have read-write access. To run the Watershed Atlas Generator tool, we just need a couple of things. You'll need a copy of ArcGIS. We designed this in 10.0, so you'll need at least 10.0. You'll also need a copy of the Spatial Analyst license, because we use Spatial Analyst to do things with the raster. And then, of course, a Python installation, which should come with ArcMap. To operate the tool, you open the digital watershed map document. I've got mine open already, so I'll show that to you. And what the map document does is it provides a template for our digital watershed maps. Notice that some of the layer sources are not defined here. That's okay, the script defines these dynamically based on what watershed we're working with. You are welcome to modify this and customize this as you'd like, but be cautious in what you do. To run the Digital Atlas Watershed tool, we first need to find it. So open your catalog window and browse to the Digital Watershed geodatabase that shipped with the distribution. I have it shown here, and inside of that, notice that it has the Atlas toolbox with our script tool. It also contains some sample data. This DEM is a DEM for Utah, and this HUC8 is also the HUC8 watersheds for Utah. The USA States shapefile is used to be a background for the inset map that's used in the template. So to run the tool, just double click on the script tool here, and it will bring up this interface. We have the 4 inputs shown here that our script uses. They're the same that Scott talked about earlier. And I wanted to show you a nice feature of this interface is that it's got this dynamic help as you click on each of the inputs that will help guide you in what are appropriate inputs for these fields. For more detailed help, you can select the Tool Help button down here, and it will open up the HTML help document that ships with the distribution. You can also access this in the documentation folder. Let's go ahead and run the tool now. First thing I need to do is select an appropriate DEM. I'll go ahead and use the one that we provide in the distribution, this sample DEM of Utah. And also I'll use the HUC watersheds for Utah in the digital watershed database. This stream threshold I'm going to leave as is. Seems to work well with this data. And now I'm going to define the name of our output PDF. I'm going to call it My Atlas. Alright, and we'll go ahead and hit OK to start running the tool. Now the script, you'll notice, is putting out a little bit of information here for us to see so that we know where it's at in the process. Right now it's telling us the name of the first watershed that it's running. And we're not going to sit and watch it because there are 57 of these and it will take a very long time. So we'll come back when this is done and show you the results. Alright, welcome back. Our tool has executed properly. You can see this is what the output looks like when it's finished, and if you scroll up you can see how it updated us with every watershed as it was being completed, and then when the map was being created for it. So that's nice, so you can see that it is working. Let's go ahead and close this and go take a look at our results, which are here. We'll open up this PDF file. Here's the default title page that we created that comes with the distribution. Let's go ahead and take a look at one of the maps. So here's one of our maps. Notice it's nicely framed and the watershed is highlighted here in the inset map. Zoom in a little so you can see some detail. The watershed, notice the sub-basins here. Something we noticed is that there were some discrepancies often with the HUC watershed, which is the red outline, and what our watershed delineation tool delineated from the DEM, which is how these subbasins were generated. So this may be a good document to show that there could be some review of these HUC8 watersheds. Alright, that is the output of the Digital Watershed Atlas generator. This concludes our presentation on the Digital Watershed Atlas generator. Thank you for listening, If you'd like to obtain a copy of our software, please email us at ciwater.byu@gmail.com. As always, donations are welcome.